SpaceX once spoke openly about building a city on Mars within the next decade. But on February 9th, 2026, the company made something clear. The moon would come first. SpaceX moved Mars further out. China's 2033 roadmap stayed active, and a strategic gap began to appear. For several years, SpaceX had the most visible private plan for reaching Mars. The idea was simple in theory: send fleets of ships to Mars during the planetary launch window. That launch window appears only every 26 months. So if a spacecraft misses one window, it must wait more than 2 years for the next opportunity. This plan captured attention because it seemed bold and fast. It suggested that the first humans could reach Mars much sooner than many government programs expected. But on February 9th, 2026, SpaceX changed its near-term focus. The company did not abandon Mars. Instead, it acknowledged something important. Mars is harder than people often assume, and before Mars becomes possible, another destination offers a faster path to progress. The moon sits about 3 days away from Earth. Mars sits tens of millions of kilometers away. That difference shapes the entire development cycle. Space missions improve through repetition. You launch, you learn, you fix it. Then you launch again. But that cycle only works when launches can happen often. Mars does not allow that. Launch opportunities to Mars appear every 26 months. That timing comes from orbital mechanics. It cannot be changed. If something fails, engineers must wait years to try again. The moon does not have that limitation. Spacecraft can launch toward the moon roughly every 10 days. That means engineers can test faster, fail faster, and fix faster. So when SpaceX shifted toward the moon, the decision was not emotional, it was structural. This was not a shift in ambition, it was a constraint. There is also an economic reason. Mars offers no near-term revenue pathway. There are no contracts waiting on Mars, no infrastructure, no market. It is a destination for exploration. But exploration alone does not sustain a launch system. The moon is different. NASA has already awarded SpaceX a multi-billion-dollar contract to develop the human landing system version of Starship. That contract supports real testing, real launches, and real iteration. The moon also allows other possibilities: surface experiments, communication systems, early infrastructure. None of that guarantees a lunar economy. But compared to Mars, it creates a path that can be funded. That creates a funding and testing cycle. Funding allows more launches. More launches improve learning, and faster learning improves reliability. Mars does not yet have that loop. The moon does, and that difference shapes where engineering effort goes. So the shift toward the moon reflects two realities: faster engineering cycles and actual revenue. But the most important reason Mars timelines moves is physics. The heaviest object ever landed on Mars is the Perseverance rover. It weighs about 1 ton. Now compare that to what a human mission needs. A crewed lander must deliver at least 20 to 30 tons to the surface. That is a massive jump. And Mars creates a very specific problem. Its atmosphere is about 1% as dense as Earth's. It is too thin to slow heavy spacecraft with parachutes alone, yet thick enough to generate extreme heat during entry. This is the Mars entry, descent, and landing problem. No system has ever demonstrated how to land 20 to 30 ton payloads on Mars. That capability does not exist yet. There is another layer. Getting to Mars requires orbital refueling. Starship must first reach Earth orbit. Then tanker vehicles must dock and transfer fuel. That process must repeat multiple times. Only then can the spacecraft leave for Mars. Each of these steps add complexity. Docking must be precise. Fuel transfer must be stable. Timing must be exact. And all of it must work together without failure. These are not single-point challenges. They are system-level challenges. Orbital refueling has not yet been demonstrated at an operational scale. It is technically possible, but it is not yet proven in real missions. So, when SpaceX slowed its Mars timeline, it was not abandoning the goal, it was acknowledging physics. The Moon offers a different path. It allows engineers to test these same technologies closer to Earth. Reusable rockets, large landers, refueling systems, surface operations. And because the Moon is nearby, problems can be fixed quickly. Crews can return. Hardware can be inspected. Systems can be improved in shorter cycles. So the path to Mars may still run through the Moon first. Not as a detour, but as a necessary step. While the US side pivots, another timeline remains active. China has publicly stated that it aims to land humans on Mars around 2033. That is not a concept, it is a declared national objective. China faces some major challenges. The Long March 9 rocket has not flown. Nuclear propulsion is still in the early stages of research. Orbital refueling is not yet demonstrated. And the physics of Mars landing remains unsolved for everyone. So the timeline is highly ambitious. But it is still active. That distinction matters, because at this moment, China is the only major program with a state-backed human Mars target. This reflects a different model. China's space program operates through centralized planning. Funding is allocated at the national level. Missions are sequenced years in advance. And long-term goals can remain active even without immediate economic return. That structure does not remove technical risk, but it does remove one type of constraint: commercial pressure. Now look at the comparison. SpaceX once led the visible roadmap to Mars. It is now focusing on the Moon. NASA does not currently have a funded operational architecture for a human Mars landing. There are studies, there are concepts, but there is no defined system. China operates differently. Its program does not depend on market demand. It does not rely on contracts tied to another destination. It can pursue a Mars timeline even if the path is uncertain. So three constraints appear. SpaceX is constrained by commercial incentives and engineering physics. NASA is constrained by funding cycles and the absence of a defined Mars system. China is constrained by unproven hardware and an ambitious timeline, but not by commercial trade-offs. That creates a strategic difference. The United States leads in many areas: reusable rockets, private launch systems, satellite networks, international partnerships. But Mars requires something else. It requires a clear operational plan. Right now, that plan on the US side is less defined than it once was. The February 9 shift did not end the Mars vision, it moved it further into the future. And in doing so, it created a gap between ambition and execution, a gap between what is possible in theory and what is funded in practice. China's plan may succeed, it may not, but it does remain active, and that alone changes the structure of the race. Mars remains the hardest destination humans have ever attempted. Distance, atmosphere, landing physics, long travel times, all combine into a single constraint. But Mars is also something else, the first human presence on another planet, and that presence will not just be technical, it will be political. Because the Outer Space Treaty, written in 1967, does not define how Mars resources are governed. It does not define operational control. It does not define precedence. It was written before Mars settlement was ever realistic. That creates a gap, not just in technology, but in governance. The first presence on Mars would not automatically define the law, but it could define the first operational norms. where vehicles land, how surface zones are treated, what counts as accepted access. And once those patterns are established in practice, later governance frameworks often have to adapt to them rather than replace them. SpaceX built the most visible private roadmap to Mars, and on February 9, 2026, that roadmap moved further into the future. NASA does not currently have a funded operational architecture for a human Mars landing. China continues to aim for 2033, and the legal framework governing Mars remains incomplete. So if no U.S. program is actively targeting Mars before the early 2030s, and China reaches the planet first, who defines what happens next?